Hi everyone, welcome to My Max Academy. In this video, we'll continue with the chapter matrices from your 12th standard CBSE mathematics. So we'll continue with exercise 3.2 in page number 82. Page number 82 of your textbook, problem number 13, 1-3. So what it says is f of x is given as this matrix. We have to show that f of x into f of y is equal to f of x plus y. So show that f of x into f of y equal to f of x plus y. Let's try to find what is f of x plus f into f of y. So f of x, I'm starting with LHS, we have to prove RHS. So f of x into f of y will be equal to, f of x is this matrix which is cos x minus sin x 0 and sin x cos x 0 0 0 1. So this is our capital f of x. Then so our f of y will be wherever x is there, we have to put y in this. So our f of this is our f of x, our f of y will be cos y minus sin y 0 and sin y cos y 0 0 0 1. So wherever x is there, we have to put y. That will be f of y. So this is your f of x, this is your f of y. So we should multiply them and we should show that it is equal to f of x plus y. Now let's do the multiplication I'm doing here. Right? Start with, so again, first row with first column. First row with first column. So cos x into cos y is cos x cos y plus minus sin x into sin y will give you minus sin x sin y. Then plus 0 into 0 is 0. So that is the first element. First element is with the first row, first column will give you the first element. Then first row, second column. That will give you the second element. So cos x minus sin y is minus cos x sin y plus minus sin x cos y. Again it will become minus sin x cos y. Then 0 with 0 will give you 0. That is your second element. So the first element, second element. Second element is obtained by multiplying the first row with the second column. That will give you the second element of the first row of the resultant matrix. Then again this row with the third column. First row with, so cos x into 0 is 0, minus sin x into 0 is minus 0, plus 0 into 1 is 0. Right? So this is your first row. Now I'm moving on to the second row. Second row with first column again, multiplication. So sin x into cos y is sin x cos y, then plus cos x into sin y is cos x sin y, then again 0 into 0 is 0. So this into this plus this into this plus this into this. Now again second row with the second column will give you this element. So sin x minus sin y is minus sin x sin y, cos x cos y is plus cos x cos y, 0 into 0 is 0. Then third element of the second row is second row of this with the third column. So sin x into 0 is 0, cos x into 0 is 0, 0 into 1 is 0. The last one is with the third row. Third row should be multiplied with the first column. So 0 into cos y is 0, plus 0 into sin y is 0, plus 1 into 0 is 0. So similarly, third row with the second column will give you this element. 0 into minus sin y is 0, plus 0 into cos y is 0, plus 1 into 0 is 0. Then again, third row with third column will give you 0 into 0, 0, plus 0 into 0, 0, plus 1 into 1 is 1. Right? Now if you observe this is cos x cos y minus sin x sin y becomes cos of x plus y. The trigonometric formula. What is cos of x plus y? Is cos x cos y minus sin x sin y. So cos x cos y minus sin x sin y can be, this whole thing can be written as cos of x plus y. Similarly here, if I take minus common, then if I take minus common, it will become sin x cos y plus cos x sin y. That will become sin of x plus y. What is the sin of x plus y? Sin x cos y, which is this, plus cos x sin y, which is this, and there is a minus So that will make both the term minus. So if I take minus common from this, then here we will see sin x cos y plus cos x sin y. That becomes sin of x plus y. Then 0, 0, 0 is 0. You have to know the trigonometric formula to convert this given into this, because both are equal. Now again, this is sin x cos y plus cos x sin y is, again this will become sin of x plus y. Then here if I take minus common, no, we need not take minus common, we can directly write. So cos x cos y minus sin x sin y is cos of x plus y. Because cos of x plus y is again cos x cos y minus sin x sin y. It's like this. Then that is 0. Then 0, 0, 0, 0, 0 plus 0 plus 0, 0, 1. But what it is? What is this? This is nothing but, so wherever x is there, we are seeing x plus y, x plus y, x plus y, x plus y, wherever x is there. So if it is x here, it is f of x. So x plus y means this will become f of x plus y. This whole thing is what? F of x plus y. Because f of x plus y is what? F of x plus y is cos of x plus y minus sin of x plus y, sin x, then 0, then sin of x plus y, cos of x plus y 0, 0, 0, 1. So wherever x is there, if I replace with x plus y, I will get f of x plus y. So f of x plus y means in this, I have to put wherever x is there, x plus y. So I put x in the place of x, x plus y, to become cos of x plus y minus sin of x plus y 0, sin of x plus y, cos of x plus y 0, 0, 0, 1. So this is nothing but what? This is nothing but f of x plus y. So we have proved f of x into f of y is f of x plus y. Right? So the left side what we have is f of x into f of y. F of x into f of y, that's what we have to the left side. That is equal to f of x plus y. So we have proved. Right? So all of you can take the notes. I will erase and probably here I will write the 14th problem in your book, the first subdivision and the second subdivision. You can do it by yourself, DIY. Do it yourself because it's just a multiplication. There are two matrices given. You have to show that A into B. If you take one matrix as A and another matrix as B, you have to prove that A into B is not equal to B into A. So you have to multiply the matrices on the left side and multiply the two matrices on the right side and show that they are not equal. Similarly, second part also, you have two matrices on the left side. Multiply the two matrices on the left side, you will get one matrix. Multiply the two matrices on the right side, you will get another matrix, so that they are not equal. Fine. So that can be done. It's a normal multiplication. So I am not doing it. You can do it. So 14th problem is homework. And I will do the 15th one. Probably you can copy this. I'm going to erase 13. So 15th problem is, so 15th one, what is given is A is given, matrix A. That is A matrix is, so this is given in the question, 2, 0, 1, 2, 1, 3, 1, minus 1, 0. This is your matrix. Now we have to find what is the value of A square minus 5A plus 6I. You have to find the value of this. You have to find the value of this matrix. So we just need to substitute in the place of x and in the place of A square. So before that we need to find A square. So we can substitute A as this matrix here. And 6I is what? I is, if it is not given, it is understood that it's an identity matrix of order 3. So I will be always same as the order of A. Only then you can add them. So I will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So the order of I will be same as order of A. Order of A is 3 cross 3 means I also should be 3 cross 3 and it is an identity matrix. And we know identity matrix means the diagonal elements will be 1 and the non-diagonal elements will be 0. Now we know I, we know A. Now let's find A square. Solution is what? A square is, see, this I is not given in the question, but it is understood that I is a unit matrix or identity matrix. Generally the symbol I is used for identity matrix. So I is an identity matrix of order 3. So you have to take I as this, even though they have not given in the book what is I. But mostly in the exam they will say what I is. Even if they don't say, suppose I is always your identity matrix of same order as A. Now A square we have to find. What is A square? Let's find. So we need to find A square so that we can substitute here. Then we can substitute this A here and we can substitute this I here and then do the calculation or simplification. You will get finally one matrix. So A square is what? We have to do A 2 times. We have to multiply A 2 times. Don't square each element of A and call it as A square. A square is not just by squaring each element of A square is multiplying A with itself. Multiplying A with itself. So A is what? A is 2, 0, 1, 2, 1, 3, 1, minus 1, 0. So this is your A matrix. Fine. So we have to multiply A with A to get A square. So A with A, 2, 0, 1, 2, 1, 3, 1, minus 1, 0. Fine. Now let's multiply. So how do we multiply this? So 2 into 2, first row with first column, 2 into 2, 4, plus 0 into 2 is 0, plus 1 into 1 is 1. Right? So first row with first column. This into this, plus this into this, plus this into this. Now again first row with the second column. This is 2 into 0, 0, plus 0 into 1 is 0, plus 1 into minus 1 is minus 1. Then first row with the third column, 2 into 1 is 2, plus 0 into 3 is 0, plus 1 into 0 is 0. Now we have to go to the second row for this. So it will be second row with the first column. So 2 into 2, 4, plus 1 into 2 is 2, plus 1 into 3 is 3. Fine. Now second element of the second row. So which will be second row of this with the second column. So 2 into 0, 0, 1 into 1 is 1, 3 into minus 1 is minus 3. Then again 2 into 1 is 2, 1 times 3 is 3, 3 times 0 is 0. The third row, 1 into 2 is 2, plus minus 1 into 2 is minus 2, plus 0 into 1 is 0. Then 1 into 0 is 0, minus 1 into 1 is minus 1, 0 into minus 1 is 0. So 1 into 1 is 1, minus 1 into 3 is minus 3, 0 into 0 is 0. So what is our A square? So A square is going to become, A square is, you get 4 plus 1, 5, minus 1, 2, and this is 5 plus 4, 9, 3 minus 1, minus 2, 1 minus 3, minus 2, 2 plus 3 is 5, 2 minus 2 is 0, this is minus 1, this is minus 2. So this is your A square matrix. Now we should find this value. So that is A square minus 5A plus 6I. That will be equal to A square. A square is this matrix. 5 minus 1, 5, minus 1, 2, then 9, minus 2, 5, this one, then 0, minus 1, minus 2, 0, minus 1, minus 2. So that is my A square. Plus, minus 5 into A. A is this matrix, 2, 0, 1, 2, 0, 1, then 2, 1, 3, 1, minus 1, 0, plus 6 into I. I is 1, 0, 0, 0, 1, 0, 0, 0, 1. Your identity matrix. Right, now we should simplify this. So what do we get here? So this is 5, 5 minus 1, 2, 9 minus 2, 5, 0 minus 1, minus 2. This will be, I can put a plus, and then I can say minus 5 into 2 is minus 10. I'm multiplying each element with minus 5. 0, minus 5, minus 10, minus 5, minus 15, minus 5, plus 5, 0. Plus 6 into this. So 6, 0, 0, 0, 6, 0, 0, 0, 6. I'm multiplying each element by 6. Now we have to, add all together. Fine. So if we add all together, we get it as 5 minus 10 plus 6 will be minus 1. And minus 1, 0, 0 will give you minus 1. Okay. Fine. Then 2 minus 5 is minus 3. Fine. Then 9 minus 10 is minus 1, minus 2 minus 5 plus 6 is minus 1, 5 minus 15 is minus 10, plus 0 is minus 10. Clear? Then this is minus 5. 0 minus 5, 0 is minus 5. minus 1, 5 and 0 is 4, minus 2, 0, 6 will give you 4. So this is your answer. The value of a square minus 5a plus 6i is this. So this is your final answer. So all of you can take the notes. I'll go to the next problem, which is the 16th problem. Erasing this. 3.2, 16th problem. So what is given? Given is A matrix is given. A is given as 102, 102, 021, 203, 203. This is your A matrix. We have to prove that. We have to prove that A cube, here we have to prove that or show that. Prove that A cube minus 6A square, A cube minus 6A square plus 7A plus 2I, 7A plus 2I equal to 0. And show this, and to prove this. And where your I is, that's why I did not erase this. The I is the same, the identity matrix of order 3. So this is your I. You have to show that this whole value equal to 0 means it's a 0 matrix. It's a 0 matrix. It's not number 0. Obviously the left side is all matrices. So right side also you should get a matrix. Fine. So now we need to find the value of this. For that we have to find A cube, A square and substitute here. And A you know, we can substitute here, and I you know, we can substitute here. Fine. So solution is we have to find the value of A cube first. So for that we will find A square first. Let's find A square first. So what is the value of, I'm writing here. So what is the value of A square? A square is, I'll put solution here. Solution is we are going to find A square. A square is A into A. And that is equal to, what is A? A is 102, 021, 203. This into the same 102, 021, 203. That will give you your A square. So the what will be our A square if you multiply? So I'm writing equal to, right? So again 1 into 1 is 1, plus 0 into 0 is 0, plus 2 into 2 is 4. Fine. Then next element 1 into 1. So first row with the first column. 1 into 1 1, 0 into 0 0, 2 into 2 4. Then first row with the second column. 0 into 1 into 0 0, 0 into 2 0, 2 into 0 0. Again 1 into 2 is 2, 0 into 1 is 0, 2 times 3 is 6 plus. Then again 0 into 1 is 0, plus 2 into 0 is 0, 2 into 1 is 2. We are doing again second row with the first column. Then second row with the second, 0 into 0 0, plus 2 into 2 4, plus 1 into 0 0. Then 0 into 2 0, 2 into 1 is 2, 1 into 3 is 3. The last row, this is 2 into 1 is 2, plus 0 into 0 is 0, plus 3 into 2 is 6, and 2 into 0 is 0, plus 0 into 2 is 0, plus 3 into 0 is 0. Right? So this into this, this into this, this into this, 0. 2 into 2 again 4, plus 1 into 0 is 0, plus 3 into 3 is 9. Now if you simplify this, or if you add them, 1 plus 4, 5, 0, 8, 2, 4, 5, and 2 plus 6 is 8, 0, 13. So this is your A square. This is your A square. Now we need to find A cube. This is our A square which we can substitute here. We have to find A cube. So what is A cube? A cube is equal to A square into A. And multiply this with A. Or A into A square, doesn't matter. So our A square is what? This matrix. I'll probably write it here. We may not have space down to write it. So our matrix A cube, fine. Our A cube is A square into A, and our A square matrix is this 5, 4, 8. 245, then 8013, 8013 into A. A is 102, 021, 203, right? So we'll multiply now. So multiplication of this gives you 5 into 1 is 5, plus 0 into 0 is 0, plus 8 2s are 16. First row with the first column. Then first row with the second column. 5 into 0 0, 0 into 2 is 0, 8 into 0 is 0. Then again 5 into 2 is 10, 1 into 0 is 0, 8 into 3 is 24. Fine. Now the second row. So 2 into 1 is 2, plus 4 into 0 is 0, plus 5 into 2 is 10. Then 2 into 0 is 0, 4 times 2 is 8, 0 times 5 is 0. Then 2 times 2 is 4, plus 4 times 4 is 1, plus 5 times 3 is 15. The third row, so 8 times 1 is 8, plus 0 times 0 is 0, plus 13 times 2 is 26. And 8 times 0 is 0, plus 0 times 2 is 0, plus 13 times 0 is 0. Then 8 times 2 is 16, plus 0 times 1 is 0, plus 3 times 13 is 39. Now, so that becomes 5 plus 16 is 21, this becomes 0, 10 plus 24 is 34, this is 12, this is 10, right? Then this is 8, this becomes 23, then this becomes 34, 8 plus 26 is 34, then this becomes 0, this becomes 55, right? So this is your A cube, your A cube. Now we should find the value of this. So we have to show that it is equal. So A cube minus 6A square plus 7A plus 2I. We have to find the value of this. We don't put equal to 0. We have to prove that it is equal to 0. We have to prove that it is equal to 0. So we cannot put that it is equal to 0. Fine. So now what we have is A cube is, we'll substitute here, A cube is 21, 0, 34, 12, 8, 23, 34, 0 and 55. Minus 6 into A square. A square is 508, 508, 245, 8013. That is 6A square plus 7A plus 7 into A. A is 102, A is 102, 021, 203 plus 2 into unit matrix is 100, 010, 001. Fine. So we have to do this, right? Fine. So if you do this, what do we get? We'll write this 21, 0, 34, 12, 8, 23, 34, 0, 55. With minus 6, you multiply this. So it will become plus. Each element should be multiplied by minus 6. It will become minus 30, 0, minus 48, minus 12, minus 24, minus 30, minus 48, 0, minus 78. Right? Then plus with the 7 you have to multiply 7, 0, 14, 0, 14, 7, 14, 0, 21 plus 2, 0, 0, 0, 2, 0, 0, 0, 2. Multiplying 2 with that. Right? Now, if you do this now, finally, so 21 minus 30 is minus 9, minus 9 plus 9 is 0. Then 0 plus 0 plus 0 plus 0 is 0. Then 34 plus minus 48 is minus 14. This is plus 14, so which is 0. Again 12 minus 12 plus 0 is 0. Then 8 minus 24 is minus 16. This is plus 16, 0. And 23, 7. This is minus 7. This is plus 7, so 0. 34 minus 48 is minus 14 plus 14, 0. 0 plus 0 plus 0 plus 0, 0. 55 minus 78 is minus 23, then 21 plus 2 is plus 23, so minus 23 plus 23 is 0. So finally your answer is 0. 0 matrix is a 0 matrix. We are representing that by this. So we have proved that a cube minus 6a square plus 7a plus 2a equal to 0. Clear? So all of you can pause the video and take the notes. I'll go to the next problem. Copy this. 17th one. So 17th problem. So what is given in 17th? A matrix is given. Given as the A matrix. And they have given the I matrix also. So what is our A matrix? A is given as, it's a 2 cross 2 matrix, 3 minus 2, 4 minus 2. 3 minus 2, 4 minus 2. It's an A matrix, and I matrix is 1, 0, 0, 1. It's an unit matrix or identity matrix of order 2. Then we have to find K, so that we have to find K. So we have to find K so that A square equal to Ka minus 2i. So to find K, given another one that is given is A square equal to Ka minus 2i, where K is a number. K is not a matrix, others are matrix. We have to find K. What we have to find? To find is K, small k. K is what? We have to find K. So it is given that A square is equal to K times A minus 2i. Let's try to find what is A square. So A is given. So solution is, we have to find the value of K. So this equal to this is given. You need not prove this. We have to find the value of K. So A square, let's find. A square is A into A. That is 3 minus 2, 4 minus 2 into 3 minus 2, 4 minus 2. So if you multiply 3 times 3, 9. 2 times 4 is minus 8. 3 times minus 2 is minus 6. Minus 2 times minus 2 is plus 4. Right? Then 4 times 3 is 12. Minus 2 times 4 is 8. And 4 times 2 minus 2 is minus 8. Minus 2 times minus 2 is plus 4. So if you simplify this, you get 1 minus 2, 4 minus 4. That is your A square. That is your A square. Now we have found A square, so we'll put this. Now we have this. A square is equal to Ka minus 2i. So A square is, we substitute the value, which is 1 minus 2, 4 minus 4. That is equal to K into A. A is 3 minus 2, 4 minus 2. Minus 2 into I is 1, 0, 0, 1. Right? So now if you try to simplify the right side, so the left hand side is easy, just one matrix. The right hand side we should make it as one more matrix, and then we should compare them because both will become equal matrix. So this is 3k. 3k minus 2 is 3k minus 2. Then minus 2k plus 2 into 0 is 0. So k into minus 2 is minus 2k. Minus 2 into 0 is 0. So you'll get minus 2k. Then 4k minus 2 into 0 is 0. So you'll get 4k. Minus 2k minus 2 into 1 is minus 2. So minus 2k minus 2. If you simplify this. Now we have to equate the corresponding values to get the value of k. So we will equate one of them. We can take minus 2k equal to minus 2. So if you take one element, any one we can compare. Either we can say 1 is equal to 3k minus 2, or we can say minus 2k equal to minus 2. We'll take this. Minus 2k equal to minus 2. This gives you k equal to 1. Now make sure that when you substitute k equal to 1 in the other three here. And so we got this k by comparing this with this. Now whatever value of k you got, substitute back here and make sure that you get 1 here. Substitute k equal to 1. 3 into 1 is 3 minus 2, which is 1. Again substitute k equal to 1 is 4 into 1 is 4. You got this. Again substitute k equal to 1 here. And minus 2 into 1 is minus 2. Minus 2 minus 2 is minus 4. Therefore k equal to 1 is the right value. If suppose if you substitute k equal to 1 in the other three, and if one of them doesn't satisfy, one of them does not satisfy the element that is coming here, then no value of k will satisfy this condition. At that time, we'll say no value of k will, so no value of k, no k will satisfy this condition. But here that is not the case. One of them is, I mean, once you substitute the value of k equal to 1, all the elements are matching. Substitute k equal to 1 here, at least in the other three, everything is matching. So the answer is k is equal to 1. Fine. So all of you can take the notes. I will pause here. You can take the notes for the 17th. So I'll stop the problem here and as well as the video here. You can watch my next video for the continuation of this. Thank you for watching. We'll continue from the 18th problem in the next video. See you in the next video. Thank you.